3. Okay, so you guys might remember yesterday we did graphing. That's the worst of the 3 methods, okay? So let me back up. A system, 2 equations, okay? A system is 2 equations. And there's 3 different ways of solving them. Graphing, which we did yesterday, nobody's favorite. We got the worst out of the way, right? I mean, it's going to come back on the review and stuff like that, but that is one of the methods. The second method, which we're going to do today and tomorrow, is called substitution. This one is a lot easier for a lot of students. And then the third method, it's called elimination. We'll start that on Thursday. That is everyone's favorite one. So if you're not great with graphing, hopefully you'll like this method a little bit better because we do it what we call algebraically. Now listen, this is really important that you understand what I'm about to say. There's 3 methods of solving a system, and there's 3 different solutions, right? We had them yesterday. One solution was where 2 of them cross. So that's one solution. You would give the ordered pair. No solution is where they don't cross. And then infinitely many solutions is where they're the same exact line. Well, you can have those same 3 answers using any method. What's wrong, Alexa? What was I saying? So understand that no matter what method you use, you're going to get the same answer, and I'm going to prove that to you. So what I'm about to teach you is the substitution method, okay? If we were doing the graphing method, I would have to put them both in slope-intercept form, pull out the M and the B, graph, make the lines. Where did they cross or not cross or cross everywhere? And we did all that yesterday. Today, using substitution, what you need to have happen is one of the 2 equations, at least, they could both be this way, but at least one of them has to have a variable by itself on one side. Y equals or X equals. And all the problems today will have that, where one of the equations, at least, it could be both, has a Y by itself, okay? And what you're going to do is use substitution, which you guys already know what substitution means. It means plug in. And I remember we talked about substitution at the beginning of the year, and I feel like it was Gabe and I don't know why I remember this, but I was talking about substitution in a sport, like in soccer, in basketball, in football. You sub out a center for another center, right? Like you take that player out and you substitute in another one called subbing. Substitute teacher. Take me out of my classroom, substitute somebody in my position. Substitution. So what you're going to do is find the equation that has a variable by itself, and of course that second one does. And I'm going to take whatever y equals. Who cares what it is? We don't get to judge. Okay? Y equals whatever's in that purple box. I'm going to plug it in for y in the other equation. So all of that is going to go in right here. I'm going to take out this y where my pen is, and I'm going to plug all of that in. And I'm going to go right over here and do that. So I would have 3x minus. When I take that out and plug that in, I'm going to put it in parentheses. Because remember, that negative in front goes to y. Well, y happens to be a binomial now, so we have to apply the negative to everything in the parentheses. Then there's an equals and a negative and a 7. So all I did was take whatever's in that box and plugged it in, substituted it in for y in the other equation. And now you solve it. A lot of these problems are going to have the same steps every single time. Remember, so there's an x, just an x in this problem. We want to solve for x. Whenever you have parentheses, you're probably going to have a distributive property going on. So if it helps you to cover up that beginning part, that's a negative 1 basically, times 4x would be negative 4x, and a negative 1 times 11 is negative 11. Everything else, I'm just going to bring it straight on down. Okay. Then you have like terms on this. So this is going back to day 1 in this class of solving equations. We have like terms on the same side. 3x minus 4x is negative 1x or negative x. If you write the 1 in front, it's not wrong. Okay. So 3x minus 4x is negative x minus 11 equals negative 7. rest of this should be pretty simple, right? Add 11 to both sides. And you, of course, can use your calculator. I'm doing this in my head. Negative 7 plus 11 is 4. And I saw some of you do this yesterday where you would leave, like yesterday you were solving for y, you were getting things in slope-intercept form, and you'd get to negative y equals something and you'd stop. Well, just like right here, this x is not by itself, right? That's considered a negative 1 in front. So I would have to divide both sides by negative 1. And I just got x equals negative 4. What that's telling me is this is going to be one solution. It's going to be an ordered pair where the x value is negative 4. Now I need the y value. Remember, if you have one solution, if you graph it, it's going to cross an ordered pair. So whenever we had one solution, we would have an answer that was an ordered pair. It hasn't changed. Our answer is still going to be an ordered pair. We just found the x. We now need the y. Fun fact, you can plug this x equals negative 4 into either equation. Doesn't matter which one, but you're going to plug in for x, right? If x equals negative 4, you can put it right here, or you can put it right here. One of them's a lot easier than the other one. This one, right? Because y is already by itself. All I have to do, y equals 4, plug in negative 4 for x, plus 11. You're just basically substituting again. But just so you know, if you plug the negative 4 into the first equation, you'd get the same answer. It doesn't matter which one you plug into. Find one that's easier. And today there will always be one that's easier, and that's the one that already has y by itself. And then just simplify this side. 4 times negative 4 is negative 16 plus 11. And y equals negative 16 plus 4 is negative 5. I don't know why I blanked on that. Negative 5. So that is the answer to that first one. That is the solution to the system. It has one solution, and that is the solution. Let me show you something on my graphing calculator. Okay? I want to prove to you that if I put these both in slope-intercept form, and I did it beforehand, I took that first equation and I put it in slope-intercept form. You don't need to do that. You just sit back and watch. So just like you did yesterday, you put it in slope-intercept form. When you do that, that equation would have been 3x plus 7. Okay? This one's already in slope-intercept. That's 4x plus 11. You're going to see that when I graph these, they cross at this point. The solution isn't different just because the method is different. It's the same answer to a system. Okay? And you can see there's the two lines, and I will even show you, so it tells you at the bottom where they intersect. They intersect at negative 4, negative 5. Where do they cross? At negative 4, negative 5. Now, I know you're not having to use a graphing calculator or anything. I just wanted to show you that the point I'm making is whether we use yesterday's method, graphing, or today's method, substitution, the answer would have been the same. The answer doesn't change because the method changed. Okay? Let's do another one. At the top of the next page. I'm very zoomed in. Okay, we're going to solve by substitution. So get it in your brain now. Solving by substitution, one of the two equations has to already have a letter by itself. Every problem you get today will have that, okay? So I see, oh, y is by itself. So I'm going to substitute what y equals in for y in the other equation. Okay? So I have 3x minus 2. Now remember, a number and a letter right up against each other like that is multiplication. So that's 2 times y. So that means I'm going to do 2 times this y. I need to put it in parentheses. Right? 2 times y. And then finish it, equals negative 17. And now this is just a multi-step equation. I'm solving for x. The minute you guys see those parentheses, check to see if there's distributive property. And there is. And if it helps you to cover up that front part and see what you're distributing, then do it. But know that you're distributing a -2 to both of those. So -2 times 2x is -4x. -2 times 2 is -4. And I'm just going to bring down all the other stuff that I wasn't working with yet. Same steps as the last problem. We have like terms on the same side. 3x minus 4x happens to be -1x again. It's not always going to be that, by the way. Minus 4 equals -17. And I'm trying to get x by itself. Add 4. And don't forget, that's like a -1 in front of the x. You would divide both sides by -1, and x equals 13. Okay, so that means I have half of my answer. I have x, I need y. I can plug 13 into either equation for x, right? If x equals 13, I can plug it in here, or I can plug it in here. It's always easier to plug it into the equation that has y by itself. So that would be y equals 2 times 13 plus 2. So all I did is plug that x value right into that equation. Yep. Oh, thank you, sorry. Let me give you a chance to catch up. So x is 13. I just plugged it in right there. So 2 times x is 13. So go right to your calculator if you need to. 2 times 13 is 26. And 26 plus 2 is 28. Yep. No, we're doing substitution today. We did the graphing method yesterday. But Alex, since you asked, if I did put that first one in slope-intercept form, I pulled out the m and b for both of those, graphed them, where would they cross? Where would these two lines cross? Anybody? Guys, No. Listen. Remember what we just did on the first one. This is important, okay? And I don't know if you guys weren't paying attention. We solved this first one just a second ago, and we got this solution, okay? Then what did I do? I put them both in slope-intercept form, the same equations, right here. I put them in my calculator. So this, in my calculator right now, are these two equations in slope-intercept form. I graphed them, and I told you where they crossed. When I graphed these two, where did they cross? In my graphing calculator, where did they cross? Right here. It's the same answer. It's just a different way of getting to it, okay? We used substitution and got this solution. If I had graphed it, I would have that same solution. So let me ask that question again. If I graphed these two, where would they cross? 13, 28. Same solution. Guys, the answer doesn't change. The solution to a system is an ordered pair. You get it on by graphing where they cross. That's how we got the answer yesterday. So if I graphed this, these two lines would cross at this exact point. It's just a different way of solving it. The solutions are not going to be different. Okay? Okay. Go over to, there it is. Example 3 on page 325. I'm going to show you some easier ones. Because remember, there's 3 different types of solutions. I just did 2 examples with you where the solution was one solution, and that answer is always going to be an ordered pair. But remember, we have no solution, we have infinitely many solutions. So we know what that looks like on a graph from yesterday. What does that look like when we do this method? It's actually easier than the other ones. So watch. Okay, use substitution to solve. Okay, find the equation that's got y or x by itself. Here it is. And I'm going to plug it in for y in the other equation, just like we did. Yeah, no. 4x plus 2, going to take out that y and plug that y right in, equals negative 8. Nothing has changed, because technically you wouldn't know that this is going to be a different type of solution. You're just doing the same method. Distribute. So that's a positive 2 this time. 2 times negative 2x is negative 4x. 2 times negative 4 is negative 8. Bring down everything else. It equals the negative, the 8. And don't forget, there was a 4x out in front. The next step is to combine like terms on the same side. We have 4x minus 4x. What does that become? If you have 4 x's and you take 4 x's away, how many x's do you have left? 0. They cancel out. That is a sign that you're not going to get one solution. We have no x's. All that we have left is negative 8 equals negative 8. That means you're going to either have no solution or infinitely many solutions. Here's how you tell the difference. Is this a true statement? Is negative 8 equal to negative 8? Yes, this is true, right? That means your answer is infinitely many solutions. What that means is if I put them both in slope-intercept form and graphed them, they would have the same m, the same b, and they'd be right on top of each other. That's how it looks when you graph it. When you do it algebraically, using substitution, your x's will go bye-bye, and you decide if that's true or not. True means infinitely many solutions. Last example will be one that is no solution, so you can see what that looks like. You will have one of every type in your notes. Okay, so change the check to this problem. And again, substitution. Find the equation that has an x or a y by itself and plug it into the other equation, just like we've been doing. So I have 6x minus 2. Take out y, plug in what y equals. I see parentheses. I know I'm going to have to distribute negative 2 to both of those. Negative 2 times 3x is negative 6x. Negative 2 times 9 is negative 18. Bring everything else down.